Let's take a look at section 4.1 example 9, where they throw a ball. Okay, a ball is thrown, I guess straight up. Yeah, thrown upward. An initial velocity, so at 64 feet per second from 80 feet, a height of 80 feet. And they want us to find the position function. Well, in order to do that, we need to know some physics. And in this case, if we want to know our position function s of t, well, we do need to know some things. So if s of t is position at any given time t, then s prime of t equal v of t is velocity. Okay, velocity at well, it's just velocity at time t, and then s double prime of t, the second derivative of s, or the first derivative of velocity, is a of t, and that is acceleration. Okay, so all we know really about the ball in terms of general physics here is that the acceleration is just gravity. Okay, and so a of t is equal to a constant minus 32 feet per second squared. Okay, so the minus indicates up is positive, and the force of gravity is accelerating objects downward at minus 32 feet per second squared. Okay, so that's what we know. Now though, we can recover, since a of t is v prime of t, I can recover v of t simply by taking the antiderivative of a of t with respect to t, and in that case I get the antiderivative of minus 32 with respect to t, but that's just a constant. The antiderivative of constant, well, that's a power rule, and the power, in this case t has the power 0 on it, so we add 1, divide by 1, we get minus 32t plus c. Okay, so we get an initial constant there. Now, it might be better, instead of writing c or c1, the book uses c1, in this case I'm going to actually say v0, okay, the velocity at time 0. And so what we know as far as v0 is that v at 0, so I'll come over here, v of 0 we were told was 64 feet per second squared, but that needs to be equal to minus 32 times 0 plus v0, and so that says 64 is equal to our v0, or v0 is equal to 64, and that's feet per second. Good reason to call it v0, okay, the initial velocity. And so this becomes, our particular solution is minus 32t plus 64. Okay, so that's v of t. Now to get s of t, well, I know that's just the antiderivative of v of t because v of t was s prime of t. So I can do that antiderivative, so that's the antiderivative of minus 32t plus 64 dt. And again, we just have a couple power rules. So I have minus 32t squared divided by 2. Okay, so I added 1 up here, and that made a 2 divided by that 2, and then plus 64t, and then plus my arbitrary constant, which I'm going to call S0, my initial position. And so this is equal to minus 16t squared plus 64t plus S0. But again, remember that we had S of 0 was equal to 80. And so our 80, our S of 0 is actually just, well, I'll put it down here and then come back to this, I guess. We have S of 0 is equal to minus 16 times 0 squared plus 64 times 0 plus S0, but we also know that's 80. And so we get S0 equals 80. And so that brings us back to S of t is equal to minus 16t squared plus 64t plus 80. And there we've recovered the position just from the acceleration. And we did have to know our initial conditions, right? We had to know S of 0 and V of 0 in order to do that. Now, again, 0 was not necessarily special. It was certainly easy, but it was not special in that, well, I guess if I had known V of 1 and S of 1, or even V of 1 and S of 10, we could have still found these answers, as long as I knew the right values for those. But here we go. We get this nice parabola, and so looking at the parabola, what a parabola does in position, then the height of this thing starts at 80, and it's going to go up. It's a parabola opening down because of negative 16t squared. It's going to go up, reach its maximum height, and then fall back down. Okay, until it hits something. And so maybe I don't know, if you threw it, but there we go. That is looking at example 9 in the text.